Hi students, in one of our videos we have discussed about the types of semiconductors, methods of doping like that. Then before we discuss about the types of two types of extrinsic semiconductors, that is N-type semiconductor and P-type semiconductor, we must know how a valency band, a conduction band is formed, and what is meant by a hole, right? Now, when we take an object, it's any semiconductor crystal, so if they are made up of germanium or silicon, whatever it is, right? So when we take a germanium atom, the first orbit of that germanium atom is called the first energy level. The second orbit is called a second energy level. The third orbit, that is the third energy level. The last orbit, that is what we call as the valency energy level or the last energy level, right? Like that. So there are n number of atoms inside a crystal, right? In a semiconductor. Okay. So since the atoms are arranged in a lattice plane like that, so if each energy level, that is as I said, the first energy level, second energy level. So if the first energy level of all the neighboring atoms are grouped together and form as a band, that is what we call as the first energy band. And if the second energy level or the second orbit of each germanium atom or silicon atom, if they are formed as a group, and they are called the second energy band like that. And if all the valence energy levels of the germanium atoms or silicon atoms are grouped together and form as a band, they are called as valency band. So these valency band may be completely filled sometimes or may be partially filled sometimes, right? And these valence electrons are also called free electrons. They'll be always moving freely, so we can easily remove those free electrons also from the last orbit, right? Even when we apply less amount of heat energy or some light energy, so acquiring the energy from those sources, these valence electrons can jump into a region where we can find the completely filled electrons, sometimes partially filled electrons, sometimes empty space. So if these electrons from the valency band jump into a region where all the atoms has formed a group or a band of energy levels, where these valence electrons jump into and then they are placed, and whenever these electrons go into this region, now the electricity or the conduction of electricity is possible in a semiconductor. So that band is what we call as the conduction band. Mostly they are empty, sometimes they are partially filled. So, for example, if this is the valency band which has some valence electrons, and if this is the conduction band, if one electron jump into the conduction band, now here an empty space or a vacancy is created, and this is what we call as a hole, which is also called as a positively charged, right? And there is a gap you can see here between the valency band and conduction band. So if it is a semiconductor and if it is made up of germanium, this gap has a value of 0.7 electron volt. If it is made up of silicon, then the gap will have a value 1.1 electron volt, and this gap is called as forbidden energy gap. So the forbidden energy gap for germanium or silicon is given here. So when we give a light amount of light energy to these valence electrons, they can easily jump into the conduction band, leaving a vacancy here, and this vacancy is called as a hole, which is also called as a positive charge or positive charge. Even they are also called as the charge carriers, that is positive charge carriers. They also pave the way for the conduction of electricity here, because when we take a p-type semiconductor, holes are the majority charge carriers. When we take an n-type semiconductor, there the electrons are the majority charge carriers, right? So this is all about a conduction band, valency band, and the forbidden energy gap. Now, and this is what about the hole. So we will look on to the type of extant semiconductors, that is n-type and p-type, in our next videos. I think you must have understood some concepts about these things, right? Thank you.